Okay, so our final set of notes in this unit for reactions, we're going to talk about the energy transfer within a reaction. Okay, so energy is used to break bonds of the reactants. So basically, the reactants have to break apart in order to rearrange to make products. So when we break those reactants apart, energy is used. Energy is released when the bonds are reformed in the product side. So we have two types of reactions. We have exothermic reactions and we have endothermic reactions. And these, all right, so let's look at exothermic. An exothermic reaction is one that releases heat or energy overall. Okay, so the overall net change in energy is a release of energy. Energy released by making new bonds is going to be more than the energy required to break the bond. So even though we're using energy to break a bond, the energy to make bonds that is released is more. So we have an overall net release of heat. And if we wanted to draw an exothermic reaction in a graph form, what we're going to see is something that looks like this, where these are the reactants. Reactants are on the left side, and these are the products. And this top part right here is our activated complex. This is where the reaction actually starts. And this is my energy. All right. And essentially, this is like my time. Okay. All right. So the products have less energy than the reactants. So energy was released. An endothermic reaction is the opposite. An endothermic is one that requires energy. So the energy released by making new bonds is less than which is required to break the bonds. Therefore, we have what we say an overall absorption of heat. All right, so energy is absorbed as heat. So if we wanted to draw an endothermic reaction, what we're going to see is something that looks like this, where our reactants are still on the left side, our products are still on the right side, all right, but our reactants have less energy than the products. So energy has been absorbed because these products have more energy than the reactants.